Hello and welcome to this lecture, where you are going to understand the brief introduction to another type of algorithm, which is instance-based learning, and the name of the algorithm is KNN. That means nearest neighbors. Let's suppose that there are 4 blue points and 3 red points. And we have this other point here, and we need to classify if it belongs to the blue category or if it belongs to the red category. We need to calculate the distance between the new point we want to classify to each one of the points that are available in the dataset. Let's suppose that these are the distance values. As we can see, 0.1, because this is the lowest distance, and as we can see here, 0.8, because this is the higher distance. And we can see here 0.3, 0.4, 0.5, and so on. The smaller the distance, the closer the points are. On the other hand, the greater the distance, the farther away the points are. The K letter in the name of the algorithm means the quantity of neighbors that you need to consider when classifying the point. Let's suppose that k is equal to 1. You are going to consider only one nearest neighbor. As we can see, the lower distance is equal to 0.1. It means that this point we don't know what class belongs to will be classified as blue. If k is equal to 2, we are going to select the two closest points, 0.1 and 0.2. So the new point could be classified as blue as well as red. If k is equal to 3, we are going to select the 3 closest points, 0.1, 0.3, and 0.4. We can see here that there are 2 red dots and only 1 blue dot. So the new point will be classified as red, 2 against 1. If k is equal to 4, we are going to select the 4 closest points, 0.1, 0.3, 0.4, and 0.5. There are 3 red dots and only 1 blue dot. So the new point will be classified as red. Finally, the last example, if k is equal to 7, then the new point will be classified as blue, since we are considering all the neighborhood points. There are 1, 2, 3, 4, 5, 6, 7 points in total. 4 are blue and 3 are red. So the new point will be classified as blue. This is how k-nearest neighbor algorithm works. To have a better overview of the calculations, we have this equation. Let's suppose we want to calculate the distance between x and y. 5, 7, 9, 5, 5, 5. We can see here that the first part of the equation is to subtract the points. So 5 minus 5 equals 0, 7 minus 5 equals 2, 9 minus 5 equals 4. This is the first part of the equation. Now we need to square the results, as we can see here. 0 squared is equal to 0, 2 squared is equal to 4, 4 squared is equal to 16. Basically, 2 times 2 equals 4, 4 times 4 equals 16. We can see in the equation this symbol here, where I am pointing the mouse, which is the summation symbol. We need to add the values 0 times 4 times 16. The result is 20. The last part, we need to calculate the square root of the result. So, the square root of 20 is 4.47. This is called the Euclidean distance. The smaller the value, the closer the points are. The higher the values, the farther away the points are. Considering this data set, we have the columns, the features of the customers, credit history, debts, properties, and income, as well as the risk, which is our objective. If the risk to give a loan is high, moderate, or low. As we have seen in the slides, some mathematical calculations are needed. So we need to convert this data from categories to numbers. For example, bad will be number 3, unknown number 2, goods number 1, debts high number 1, debts low number 2, properties known number 1, properties good number 2, income less than 15 number 1, between 15 and 35 number 2, greater than 35 is represented by number 3. Let's select these two instances, and now let's suppose that this new customer has just arrived in the bank and is requesting for a loan. The history is good, which is 1 in this representation, debts high, 1, properties none, 1, and income greater than 35, which is equal to 3 in this new representation. Now we need to perform the calculations between the new customer and all other instances of the dataset. For this example, we are going to see the calculations of only these two instances. So, we calculate the distance between the new and instance number 9. We can see here 1, 1, 1, and 3, and instance number 9, 1, 2, 1, 3. We apply the same calculation. We subtract the positions, add the values, and at the end we calculate the square root, which is equal to 1. Now we can calculate between the new 1, 1, 1, and 3, and instance number 3, 2, 2, 1, 2. After performing all the calculation, the result is 1.7. If you want, you can pause the video and try to calculate the values by yourself according to the equation I have showed in the other slide. That indicates that the distance calculating the new and instance number 9 is smaller than the other. So what we do now is to see the class or the risk for this customer, which is low. So the risk for the new customer that has just arrived in the bank will be low, the same class as the customer with the smaller distance. This is how KNN algorithm works. See you next time.